Okay. So we'll start with the accounting, the compound interest, compound savings account and stuff like that. But we'll just go directly to the tax. So the number one, create a Java file called investment1.java and create the main function. So we'll go ahead and do that. New file investments1.java. Alright, and we'll create a class, the method. So declare variables to hold the value given in the brief. So there are a couple of things in the brief that you should have read, right? So basically, if you look here, let's see. So you have, I'll just I want us to read it, but because of time, it's a bit much. The brief is a bit much, but basically, they are trying to do this. This is what we want to do. So you have new capital, which is what we want to calculate. You have the principal, which is this. You have the rate increase. Discuss above. This is the rate at which your money grows after each payment. You have the rate increase, and you have VA. Okay. Okay, let's just read the program. There are many instances where you want to know how much your initial investment has grown after a specific year. The formula below computes this. Use math.power method to calculate below. So we are supposed to calculate rate increase ratio. So we use this formula. So this is rate increase ratio. This is yearly increase rate. So there are a bit of things to check out there. The capital gain is simply the new capital minus the initial one. After 10 years, your initial capital of £100 would have grown to 1,568, given a 4.5 interest rate. Some quick explanation are given in the appendix. Thus, this minus this equals this over 10 years. So let me see if we can actually do this without reading. Basically, this is the formula we want to use, but we have to get rate increase ratio from here. And rate increase ratio is this. 1 plus yearly increase rate over 100. Okay, that's fine. Yeah. So this rate increase ratio is just calculated using this formula. The number of the yearly increase, which in our case is, the problem says it's 4.5%. Right. So all we need to do is to do the same thing that was done here, and we get the rate increase ratio. But basically, this is what we actually want. So the first one is to calculate our rate increase ratio. So you can, because what we want to do is actually much. This is where we are going. But we need a way to get the rate increase ratio first. But following the stuff, they said declare variable to all the values given in the brief. So let's say, okay, this is the value. This is the year, and this is the interest rate. So those are the three things you need to calculate the new capital. So variables, now you have, I think we can use double. The first thing is the principal. Principal equals that's 100 pounds. Actually, that's just 100 pounds. So you can say 100. Yeah. And you also have interest rate. So double, we can just call it rate, equals 4.5. And you have year, 10 years. So that could be integer, right? Int year equals 10. Right. And since you have this, you can leave it like this, or you could also do something like this. Double principal, comma, okay, principal equals 100, then comma, rate equals 4.5. This is very useful when you have many variables and they are of the same data type, so you can just merge all of them into one single line. So now the first thing we want to calculate is this rate increase ratio. So you can create a method to do that. So you can say public static, let's say void for now, get, we'll just use the same name, get rate increase ratio, right? Then this is the formula for calculating rate increase ratio, equals 1 plus yearly increase rate over 100, right? So okay, they are saying something here. Whereas rate increase is the rate at which the savings will grow after each year. It is usually 1 plus interest rate, with the interest rate as decimal. Hence, if you have a yearly interest of 4.5, this is 4.5 over 100 as a decimal. This is, since it is a yearly rate and we need the monthly one for our computation, as our need is based on monthly payment, therefore we divide the row by 12 also. So basically this is how to calculate your yearly rate increase ratio, right? But because they want in months, so they also divide it by 12. So out of those 12 months, we know for each month. So that's why you also have times 12 here. So it's like you're dividing this whole thing by 12 again. So you get each of the months. So this is the formula we want to use. That will be 1. So we can just pick the name. If you speak everyone, let's see. Rate, let's just call it double rate increase ratio equals 1 plus the brackets. Now this is where the important bit comes into play, dealing with brackets. So your bracket, then your yearly interest rate, which in our own case we don't know, we know is 4.5, but we want to calculate based on that. So since this is a formula, this is a variable that we're expecting. So we can say we're expecting an integer year, no, rate, not year, and that would not be integer, that would be double. We're expecting you to pass rate into this thing, when you want to call this rate increase ratio, you should pass rate into it. So we'll collect that rate, right, over 100. But this is fine, but then because we needed by month, we also need to multiply 100 by 12. So now this is one problem most people will have. They might decide to just do times 12. This looks the same thing as this, but it's not the same. Is anybody following me? Hello?
Anthony, we are with you.
Okay, now this is what
I can hear you.
this thing right here. This 100, this is 4.5 over 100 times 12. That's the same thing I've written, right? Rate, let's just call these, let's call 4.5 rate. So rate over 100 times 12, rate over 100 times 12. Is this the same thing as this? That's one thing I want anybody. Can you answer this? Is this thing here the same thing as this? Taking this 4.5 as rate. Anybody? Hello?
Yeah, I think it's not the same because the 100 times 12 should better go in a bracket.
Yeah.
So that's, you can see that's one component.
Exactly. So what you just did here right now, even though it's not looking like it is rate times 12 over 100, because at the end of the day, what the calculator will do is PODMAS. It will do the multiplication first, then do the division after. But if you introduce brackets, because this here is a single entity, so you need to make sure you group them using their own brackets. So what you are saying, right, is rate over everything like this. But if you don't introduce that bracket, you are saying rate over 100 times 12 in, I don't know if I can write something. Let me see. Sorry. So basically, what you've written is rate over rate times 12 over 100, which is not what you want to do. You want to do rate over 12 times 100, right? So basically, so to make things group together as a single entity, you introduce your own bracket. So that gives you the rate increase ratio 1 plus rate over that. Then you can return rate increase ratio. Then since the rate increase ratio is a double, you change void to double. So easily here you can say your double rate increase ratio, because you need, this is, don't forget, this is where we're actually going, right? We have the principal already, but we don't have the rate increase ratio, right? We don't have this rate increase ratio. We also have GA already, but we don't have this. So we are trying to calculate this first. They gave us the formula to calculate that, which is what we've done here. So for us to be able to use this completely, we need a rate increase ratio. So our rate increase ratio now equals, go and collect rate increase ratio from here. Get rate increase ratio, then supply the rate. The rate is 4.5, so we'll just supply the rate directly like that, and we have that. So for us to do this now, we have our principal, that's this. We have our rate increase ratio, which will be calculated in real time based on our rate. We have rate increase ratio, we have rate increase ratio, we also have here. So let's write out the formula. We know at the end of the day, this should actually be a double. So we'll just say double. Anytime you are doing calculation that involves multiplication, division, just default your data type to double. Although we don't know what we're expecting, but when you start doing stuff like division, multiplication, just use double, makes your life easier. So new capital, so we'll call it, now this is a bit. Basically, you might want to write something like this in your new capital. This is wrong. You can't do this. Don't forget, you can't have name with spaces. You can't have variable name with spaces. So what you can do is new capital equals, so I've managed to join both of them together, equals your principal, right, times your rate increase ratio, right, because we have it, then times bracket, another bracket, right? Don't forget, now what you can do at this point is break things down, right? Break things down. You might want to say, okay, there are many ways to go about this. So because it can easily get complicated from this point onward, you can, let me see. Yeah, you can do this, your big bracket, just big bracket, then the first line of the bracket, which is rate increase ratio of power J. So how do you do m dot power? You supply what you want to power and you supply the power. So you supply this first. So this is what we want to do, right? We want to do rate increase ratio raised to power J, right? So we say max dot power, then we supply, note the definition here. Say double A. Now the first A is double, just means the data type of the first input, data type of the second input. So the first thing you want to supply is the rate increase ratio. The second thing you want to supply is the year. So we supply rate increase ratio, then comma, is not like you are not doing anything weird here, just comma, then year is going to do every other thing for you, then -1, right? this is just one single entity like this, everything like this is just this guy minus 1. I hope this makes sense. Then divide, right? This divide. You can just go to a new line to make things interesting. Divide, then another bracket, right? Because if you don't put a bracket, then there might be some problem with this. It might split these things. So once you have group of things, just put them in brackets. So you have rate increase ratio minus 1, and that's it. Let's take it back a bit. So you have your principal dot rate increase ratio, times rate increase ratio, then your big bracket, right? Your big bracket, then your first small bracket, rate increase ratio minus 1. That's this. The power of rate increase ratio, you know how to do power. Supply the stuff you want to power, supply the power, then that one has its own bracket. Now it looks more like what they actually have here, but after formatting to help you to rearrange everything, so you might easily not understand this, but as you are typing it, just break it down the way it is here, and just maybe you can get around it. So now let's see if we are on point. So declare and name variable properly. We've done this. We've used variables, declared them. Create a code to compute the rates increase given above yearly rate given in the above yearly rate in the brief, and store the value. I don't know what they're doing here, but this is just telling you that the first rate increase ratio we did. Right, that's just that. The English will be out of it. Declare and name properly a variable to hold the new principal. So that's new capital. Create the code to compute the capital gain and store the value for rate increase year use power function. We've already done this, so that gives us tax 1. This is let's take it one by one. Creating your file is the question 1. Question 2 is declaring all these 3 variables. Question 3 is okay, that's question. No, question 3 is the rate increase. That's the rate increase ratio, which it was this one that is calling this function. And create a code to compute. Just basically create a code to compute the rate increase given. You create the variable, right? We created the variable, then we wrote the code for it, which was this one. Then declare and name properly a variable to hold the new principal. So we are just calculating the new principal, and then create the capital gain, which was this, the new capital. Then use math.power to do this, which we've done. So that marks the end of that whole chapter. So if you just want to check your stuff out, you can check out the results you got from rate increase ratio. So you want to see what is rate increase ratio, right? You also want to see, let's just do something interesting. My rate increase ratio is, right? Then X out, my new capital is new capital, right? So let's run that. So what we are expecting is for the rate increase ratio to be calculated. To just call this and we get something. So we get 1.00375, and I think we're right on track. 1.00375. Then we'll use that 1.00375 to now calculate our new how's it called? Our new capital based on the number of years and the amount we plugged in. So I think they also did that somewhere. That's a bit different. Let's see. After 10 years, would have grown to this, but ours just grew to 1020. Is that right? Something else up somewhere. No. 4.5. Yeah, we use 4.5. Hold on a minute. Something. No, there's no one. Too much. So our rate increase ratio is correct, but the new capital is not correct. The new capital is not correct. Yeah, one thing. Hold on.
Hello,
Okay.
Anthony.
Yeah.
Okay. Thinking that the error might be from the instructor because I've actually tried it too, and what I got is what you just get now.
Okay.
So, but
Yeah.
you can keep checking, but I think the error was from you.
Yeah, let me just confirm from my code. I think I did it. Yeah, 3. My cloud class 024 3. So investment, I just need new capital. Okay, this is actually increasing. This is 100 years. I need plus 10 years. Just a minute. I just want to confirm that to be sure. Yes, increase rate. Yeah, that's yeah. Just copy and paste this. Okay, let's just run this and see. So this is 100 years. Yeah, actually, it's the same. It's the same thing. So yeah, don't mind that. If we change it to 100 and start getting fascinating. Yeah, that's too much. Okay, I think there is a question with 100 later. So I think this calculation is, I'll confirm this with him. I didn't actually check. I'll confirm this with him in the next class. Well, this might have been wrong. So let's go on. Initial amount. I think this is something else. Write the code and create 2 methods. One for the rate increase ratio. We've already done that. Basically, this could have been here, right? One, it could have been here. Let's say we take this off for a bit. This could have been here, and we say you get, well, we don't want to just plug up this place, so we don't know what this calculation might be, so we just don't want to be doing this every time, so we just put it in a function so we can always refer to it any other time we need. Like, I don't need to know this formula again. I just need to know that, okay, anytime I need the rate increase ratio, I'll just call this value. That's why we're doing this. So says we should write to the code and we should create 2 methods, one for the rate increase ratio and one for the capital gain. So we want to also bring this one out. So public static, let's say void for now. We'll come back and change it to double. Get new capital. All right. And what's the formula for calculating new capital? This is where is it? This is it. So which is this? Let's just bring it down. We've already written it, so we don't need to do much work again. We just bring it down. Now we're seeing some red things. So we can go ahead and say, okay, double new capital here is equals to get new capital, right? And supply some things into it, but we'll come to that in a minute. So all these ones that is showing, that is throwing up errors, we can just plug them as variables because they are variables. So basically what we are doing is creating new capital using all these variables. So this is variable 1, variable 2, this is the same as this, the same as this, then variable 3. So we need 3 variables to calculate new capital. So we'll plug in those values. The first one is principal. The second one is rate increase ratio. So it's also a double rate increase ratio, right? The third one is year. So those are the 3 unique things that are actually here. So plug in year. That was the same thing we did with this one. The only variable we don't know here is year increase rate. So that was why the only thing we were collecting was rate. But for the second one, there are a lot of things we don't know. We don't know this, we don't know this, we don't know this, we don't know this. Although this, and this are the same thing. So it's just 1, 2, and 3. So that gives us this one. And automatically all your values are fixed. Then you can return new capital, right? So you can return new capital and change your void to double since your new capital is a double. Then your get new capital here, you can see it's telling you is expecting a double, and an integer. The first double is principal, the second double is rate increase ratio, the third double is, you can see it here, principal, rate increase ratio. Yeah, you just over on it, that gives you the definition. So the first thing is telling you you need the principal, you need the rate increase ratio, and you need the year. So just apply it. Principal, we have principal already. So principal, then rate increase ratio, and year. So that fixes our problem. Then you can see our stuff here is getting shorter and things are getting, anytime you need to tweak something would get, like, by the time it says, okay, this is actually not correct, this is correct, like this value is correct, and it shows us how to fix it. I don't need to be reading, I just know where I'm going, because right now this is my code right now. You can see when I was looking for something I was trying to get. So your code can get, this is actually small, but your code can get really complicated that you start looking for stuff. But if everything is where they should be, you know that, okay, anytime I need to deal with capital, I don't need to read all these codes. I just need to come to get new capital and see what I was doing inside. That's it. That's the same thing we're doing here. So return that and let's run it again. It should still be good. Yep. So we get that. Then let's go to the. So the rate increase should only have 1 parameter, and the method computing the capital gain should have 3. So 1 parameter for rate increase, 3 parameters for getting your capital. So use a for loop to compute the gain for each year until the year to check the capital gain and display this information in proper manner. Okay, so what it's saying we should do is, now the value we are getting here is the value after 10 years, right? Well, we want to now get for each year, one after the other. So how do we do that? We can for loop. We know we are going to 10 years. So back to for loop from yesterday. So for loop for we'll say int I equals 0, right? I is less than, we know our year is 10, so we are actually counting from 1 to 10, but I will just show you a workaround around that in a minute. I plus plus to be sure, because sometimes the for loop can confuse and you can just do an S out to check out what I is. So I is 0 to 9, but we need 1 to 10 for our calculation, so you can easily change this to You can actually change this to 11, but we actually need the value. So I can just change this to 1 and change this to less than or equals to 10. Then we get 1 to 10, right? So we can now use our I for the calculation. So what we're passing into this J here would not be year like this again. It will be I, because our I is now each of the years. So for each of those calculations, we can now say new capital per year, right? Let's say per year equals that, and year will now be 1. So instead of passing 10 every time, we're passing 1, 2, 3, 4, 5, 6, 7, 8, 9. We know our year is 10. Bam, right? And also one thing you can do here is change this to year, since we're using variable. The reason for that is, in the case of my own code, whereby I saw 100, now I will need to start looking for where I use the 100, but because we've used year, once I change this, I don't need to start looking for anywhere I use 10. It will reflect for everything. That's why we're using variable. So we'll change this to year. Year is the same thing as 10, so we're still good. New capital equals this. We don't want to calculate for the 10 years. We want to calculate for each of the years. So instead of using year, we use I, right? Then let's see what we get. S out. We can just say initial amount, new principal, capital gain. Okay. Capital gain after 10 years. Let's just see, just a minute. Let me see what we'll get for new capital per year. All right. So 100 to 1, blah, 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 until this. I don't know where it's getting these values. Oh, this is 10. Sorry, this is 10. Initial amount is 10. So maybe if we even change this to 10, we might. I don't think that will. It still doesn't make sense. But for this will make sense. Our answer will make sense for this one. So you can see this. So let's do the same thing it did. Initial amount, that's our principal, is 10. So let's S out. S out. I'll use printf because it's a bit long. Printf, I want to type the same thing you did here. I can't copy, so I'll just type it out. Initial amount, right? Amount, interesting. Amount is something we don't know. We'll just use percent dot. We can see that it's in 2 decimal places, so we'll do .2f. That gives us our initial amount. Then new principal. We don't know that one yet. It's also 2 decimal places. That's fine. 0.2f. Then capital gain. Something we don't know that yet. So it's also 2 decimal places. .2f. And years after 10 years. So after percent %d, because it's a year will be an integer, so we use %d. So let's slot in the value. First value is initial principal, which is 10. Which is principal, right? The second one is the new principal, which will be new capital per year. So new capital per year. The third one is capital gain. So that will be new capital per year minus principal. You can calculate that separately, or you can slot it in here, anything that works. And let me just calculate it separately. So I can say double capital gain equals new capital per year minus capital, right? The original principal, sorry, the original principal. So we are just trying to check what was the gain. So the new capital for this year minus what I deposited initially. So that gives us capital gain. So capital gain, then year, right? So let's do that and see what we get. That's ugly. Let's take it off a bit. So that gives us the last one. Initial amount, which is 10. I think they just printed the last one. Initial amount is 10. New principal is 102.09. Capital gain is 92.09. And after 10 years. So that is good. So yeah, let's go to the next one. In this exercise, you want to discover how many months are needed to accumulate a specific capital. How many months before your account reach 3,000 wanted principal. So what they're trying to get is how many months will it take you for this new principal to be 3,000, right? So given an initial principal of 100, given the information in the brief, you would have to wait 29 months to finally have this amount. So if you have 100 originally, and the interest, you have an interest of 4.5, you will have to wait for 29 months for you to have 3,000 in your account. This is what you are going to code. Write a method to compute this value. Use match.log. Okay, this is the formula to do that. This is what we're trying to do right now. So we want to calculate the number of months. We have been given the wanted principal. We've been given principal. We have been given rate increase. Yeah, we've been given rate increase, and so the only thing here is principal, wanted principal, then rate increase. I'm guessing this rate increase is would be this rate increase ratio. So we have all that. We have principal. We have this. This is 3,000. This is 100. This is something we'll calculate. So let's do that. Right. So I want to calculate the number of months. So we can just write a new method for this. So it says public static. We know we'll be expecting double. Let's just do this for now. Get months, right? And we don't know what we're okay. We actually know. We know we need principal. Principal is going to be double principal. We need wanted principal. So it's also going to be double wanted principal, and we need rate increase. That will be rate increase ratio. So let's also say double rate increase ratio, and well, I guess that's it. Yep. And let's see. And let's write the formula. Double months equals. So for you to use log, they told you what to use a math.log, right? So we say math.log, and we supply the first bracket. We've been given the first bracket, then we need the second bracket, the second bracket, then we want wanted principal divided by, now everything here, everything under the divide by is going inside the bracket. So the first bracket, then this one, sorry, 1 minute. Stop doing that. Really? Okay. What was I saying? Yeah. So we've done wanted principle, that's this. So all these things like this. Now, this is where you should be careful. There are some times where the brackets, the ones we've been sent before, the brackets are accurate, they are correct. But this one now is missing one very important bracket. The bracket that combines. Now, all these things like this, like, I don't know why it's doing this. This from this bracket to this bracket is one entity. So even though they have their own separate entity, you still need to make sure to put all these things inside one bracket. Because if you do it the same way they did it like this, you will have wanted principle over principal times rate increase. Then you will have wanted principle times this one divided by this one. That's not what you want to do. You want wanted principle divided by all these things. But if you if you write it the way they wrote it here without introducing a new bracket, then you have wanted principle times rate increase minus 1 over just this one. That is not what you want. You want both of them. So you need to be careful to know what you're doing here. So I will introduce a new bracket before bringing their own brackets, which is now principal times rate increase. So principal times rate increase ratio, right? Then divide by rate increase minus 1. So inside is on bracket rate increase ratio minus 1. And now this is where things get a bit complicated, right? You need this plus 1. So you need to be able to know that, okay, wanted principal, you need to know where brackets start and where brackets end, right? So wanted principal, brackets after wanted principal. The brackets taking wanted principal itself. So this bracket, this yellow bracket, you want your plus 1. I don't know if you get that. Now, what I did was the brackets taking this wanted principal is one, we want to do it after that bracket. So the wanted principal started from here, from yellow, ends at yellow. Actually want it outside, right? So this is what I did. This plus 1 is the same thing as putting the plus 1 here, right? So you have your bracket, the brackets right before wanted principal. This is this bracket right before wanted principal. That's the yellow bracket, right? Then what's the corresponding closing brackets? That's also this yellow. If you're using Visual Studio Code, it comes with color coding, so that makes things a bit easier. So you have yellow, then you look at the yellow, then the plus 1 was actually after it. So your plus 1 is after the yellow bracket. Then you can continue. That gives you you need divided by, your initial bracket. So that's the bracket of the log. So your bracket of the log, like everything with your log and everything, right? Everything, your log and all over log of rate increase. So you still need another math.log of rate increase ratio. No. So that gives you your month. I know it's a bit complicated, but at least I will following. That's the main part. Like I said, it's just is mathematics. There is really no much programming going on here, but you understand, because if you mistake, even if you're using calculator, if you mistake this bracket on calculator, you will still end up with the wrong answer. So this is more like mathematics, but we're following. Hello?
Yes, please. Yes, I'm following.
Okay. So at the end of the day, you can now return months, right? And since your month is double, you have the right to change this to double. Then you can now come back here and say, because this will not normally run, but we want it to run, so we'll just come to main method and call it. So our double months equals get month. Then we supply principal. We supply principal, we supply wanted principal, and we supply increase ratio. So we supply principal, we supply wanted principal. So we're given a wanted principal, right? Because our wanted principal is 3,000. Wanted principal is 3,000. Wanted principal is 3,000. Our initial principal is going to be 100. This is supposed to be in another file, so maybe I should actually put it in another file. Investment 2.java. Right. So I'll just copy and paste the whole thing, put it here, change this to 2. This to 2, and we should be fine. Then I can take off. These ones. There are some things I will be needing here. I'll take off this one. So that concludes one. Sorry, bring it back. This concludes one. So for 2, we are told to calculate months. So we won't be needing this one. We don't need the new capital. But we need increase ratio. We don't need new capital, right? But we need the increase ratio, right? We need the rate increase ratio. So that's why we left it. And yeah, we don't need year. All we need for this is wanted principal, the principal, and the rate increase ratio. So we have principal, we have wanted principal, we have the rate increase ratio. But for us to calculate rate increase ratio, we need rate. So that's why we left this. So this changes to wanted principal, and this changes to what is that? Okay, yeah, principal, wanted principal, and rate increase ratio. So we're good. So do we have an output we're expecting? Months. So I'll just S out that. Change this to F. That's much easier. Then months needed to accumulate. Months needed to accumulate. We don't know this yet. I'll just put this first. I know how to write this. Yep. Dot 2F, right? This is just fun. It has nothing to do with it. I just wanted to type the pound, so it's coming with it. The 2F at a rate of 4.5%. That'll be %.2F, then percent. Interesting. Okay, let's see what happens. Percent is 29 months. That will be here. This should actually be an integer, but let me actually see what we get, so I know what to do with that. Can just S out it to actually see S out months. I just want to see what the months actually looks like. Yeah, so 28.3, not totally 29. So we have 28.3. What do we do? We can just round it off here, right? We can actually, because what they're expecting is month as the number of months. This doesn't really make sense. So you can easily convert this to type conversion. You can do int, then change your double to integer. So what we'll be getting is integer. So what happens to this 28 is it's cuts off everything and changes it to this is still not good, but we can always take it off. If you don't want to do this, if you want to stick with what we have before, which is double, that's also fine. You can do that, but what we'll just do here is we'll say is %.0f. So no decimal place. It's the same thing as actually converting it to is F months, given an initial is F months, given an initial investment of that spans of %.2 F pounds, and that's it. So let's slot in the values. So the first value is months needed to accumulate that's the principal, the wanted value. So wanted principal, then at the rate of the rate 4.5, that's rate, is 29 months. That's the months we calculated, right? Is months given an initial investment of, that's the initial principal, so principal, right? Okay. So we have conversion equals what's going on there? Okay, we got line 10, which is this line. So what did we do wrong? We have, okay, yeah, I was just, hold on a minute. I know what happened there. Yeah, we introduced something. That was what I was checking the other time. So I think one thing we can do with that is this. I'm not sure. That is not working. Okay, that's fine. How to write the problem. Okay, let me explain the problem. Actually, the problem is we want to use percentage, and percentage has its own usage directly in printf. So anytime there's a percentage, that means it's expecting a formatting, but we actually want 4.5%. So I need to know how to type this, how to make this percent show up in my code. So the reason why it was showing an error here is because it saw %i and it doesn't know what %i mean. Although what I was expecting is for it to type % directly, but because % is actually a function in printf, it's now seeing it as, okay, this person type %i, what does %i means? %i does not exist, so it's kind of lost. So I need to find out how to write % in Java in printf Java. How to write %. This is not good. Okay, yeah, this should be good. Okay, %. So you have to write it twice. %, and let's see if that makes sense. Yep, that gives us our %. So months needed to accumulate £3,000 at a rate of 4.5 is 28 months, given an initial investment of £100. You can also, I don't know why we're getting different answers, but you can also, don't mind me. They're using, the instruction said you should use math.cu. Yeah, don't mind me. Math.cu is you rounding up. There is math.floor, there is math.cu, there is math.rand, land, ROUND. So what this is doing here is rounding up. So if you have 2.1, for instance, I think it's going to be 3. Let's see that in a minute. Math.c. Then I'm going to do 2.1. I just want to take this off for a minute. Yeah, you can see. So that is what math.ceil does. There's math.floor. So what math.floor does is it runs down. So let's say, let's use the same 2.1. Oh no, I need this to be floor. So this just runs down. Even if you have 2.9, still floors it. 2.0. So this runs up no matter what. This runs down no matter what. So that's why it was actually getting 2.9. So I could actually say math.ceil. Math.ceil, just ceiling, just take it, at least that's how I take it in my own head. Math.ceiling, we are looking up, meaning we are trying to round up. So by default, this is going to show more happen. Yeah, this month is going to show up as yeah, this could actually be an integer, I think. No, you can't. Yeah, math.ceil still gives you a decimal. So yep, we should be fine and we should get 29 months. I don't know, does this make sense? Math.ceil is just a method in math. So we've been using math, we use math.py, we've used math.law, we've used math.power, POW, we are now using math.ceil. And this is math.ceil. I also showed you math.floor. It's just the opposite of ceil. Ceil goes up, floors comes down. Does that make sense?
Yes. Yes.
Okay, so we're done with these. Even more advanced, blah, blah, blah. This is also a real example. When performing this sort of computation, the most difficult is the position bracket. That's what we've been doing. Below is a good example. The formulas below provides a clue. Blah, blah, blah. It can get as complicated as this. You can keep on doing it, keep on doing it, keep on doing it. But we just go to the tax. So the tax says you should code the formula in the main method first. You must declare the necessary variables to all the values and blah, 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 blah. Okay, basically, what do we want to calculate actually? We want to calculate, let's see. As an int, suggestion of variable names have been used in these formulas, and the test value tables display the wanted values in the console. Once the results you display in the console as the same as the one given above, create 3 methods as shown in screenshot below. Run your code to ensure you obtain the same value. Okay, so this is what we want to actually show, right? Ratio 1.08, monthly repayment equals this. So basically, I think what they are trying to do is to calculate the monthly repayment. If you borrow this amount and the yearly interest rate is 8 and you have to pay for 25 years. Now, what is going to be your yearly interest rate? I think we can get that from yearly interest ratio, right? Is 1 point something. Let me see, do I still have it? No, I don't. I'll just run this again. My ratio, yeah, this is yeah, it's not the same thing. Hold on. Oh, this is 8. So let's try 8 if we just want to be sure of the formula we're using. That's not good. Okay. I think he has his own separate formula. Yearly increase ratio, that's this. Okay, they are not using by 12 here. Don't mind me, I just want to figure out that formula before I go ahead with it. Okay, that's good. So the formula is different. This is okay. The one we are doing before is by month. You know, they talked about it here. Is by month. So they are they are dividing it by 12. But for the new one, even though it's the same formula, it's per year, so it's yearly interest rate. So we won't be dividing the yearly increase ratio by 100. It's still the same formula. So I will just do investment 3, copy and paste, new file, investment 3.java. Oh, some stuff. Delete. Move. No, investment 3.java. Right, copy and paste, copy, paste, changes to 3. So I won't be needing this again. I won't be needing all these ones again, but I still need my increase ratio. But now the formula for my increase ratio is now different. It's no more times 12. So I can easily take that off. And if you check this out, rate increase ratio now, it's now no, okay, yeah, rate is, let's do this thing again. Loan amount, that's principal, so that's let me just copy and paste. I don't know if I can read that. Rate is 8. Rate is 8. We need year also. Year, int year equals 25, and yeah. So let's first calculate our rate increase ratio, which is using this formula. So it's the same formula as this without the 12. So we'll do that and we see. So we have 1.08. We are getting it. So now we need monthly repayment. So to get monthly repayment, this is yearly repayment. Yearly repayment is the loan amount times yearly increase ratio. We know the loan amount, we know the yearly increase ratio, we know the year, and that means we can do this. So let's do that. So we should be double because we are doing some calculation. I will just use the name directly, yearly increase amount. We can also use the same name here, yearly increase ratio. So that's yearly increase ratio, right? So for yearly payment amount, yearly payment amount equals bracket, then loan amount, that will be principal, and you can just use the correct name, loan amount. Then there is okay, I think it's called yearly interest rate. So I'll just put yearly interest. Not to confuse you, we can just, because I've been doing a lot of quick fix. So let's just take it from the top. We have a bunch of, these are test results, so we won't be needing this, but this, we need this. So we have loan amount, which they are calling loan amount. That's fine. So double loan amount equals value, I think 100,000. Right. We also have yearly interest rates. It should also be double because it could be a decimal. Yearly interest rate equals 8.0. You can do that as 8. That's fine. Years, we can call that int. Years equals 25. That's fine. Then we have this formula to calculate the yearly increase ratio. So I'll say, I'll just go and copy this one. I've already done that before. Copy, bring it here. So I can say my double yearly, what's it called? Yearly increase ratio. Yearly increase increase ratio equals get increase ratio based on the yearly increase rate, right? Then I now won't be needing the 12 because the formula is not using 12. So this per year is no more per month. So that should give me, I put S out that first, S out yearly increase ratio. That should give me 1.08, that's fine. So let's go to the next formula. The next formula is yearly payment amount. So let's do that. Double again, double yearly payment amount equals bracket loan amount multiplied by, is it multiply? Yeah, multiply by, we need power here, right? So math.power, the first one is yearly increase ratio. So yearly increase ratio, the second one is years, right? Yes, then divide by, we are dividing the whole thing, divide by, so we are dividing everything here by a bigger bracket. Then this minus this, also there is a small bracket here that is catching those this and this, so we need a small bracket, math.power again, math.power, and the first one is should be yearly increase ratio by year, so that's yearly increase ratio by year, yes, right? Then that will be minus 1, right? Then I want to divide everything there, like everything inside this purple bracket by this one. Also, I'll also put that in his own small bracket. So math.power again, math.power. Then that's yearly increase ratio. Oh, there's no power. That's good. So bracket, just yearly increase ratio minus 1. So yearly increase ratio minus 1. And I think that's it. Terminate it. Okay, and let's see what we get. S out yearly payment amount. Yeah, so you pay these like that. That's fine. To compute the yearly payment amount to cover the cost of the loan and to pay it off, this is the formula for this, which is this. However, it is sometimes very useful to split this formula as shown below. This ensures we can code method more easily, and they become reusable. Note, loan costs. Note, no loan cost, no payment below will also be used in part 2. I think there's another question. So all they are saying is this thing, instead of having it this gigantic like this very large, we could split it down into different methods and just call each of the method at every point, right? So we can, if we know, I think there's another formula at the bottom that is using the same thing. So we could, instead of writing it 2 times, we could just put it in his own method and call it. So how do we do that? You can say loan amount multiplied by this is 1. So they just gave it his own method, loan cost, no payment. So let's create that. Public, the same way we did this yearly increase ratio. So we would have been writing all these 1 plus rate over 100 everywhere. Write it here. Like we would have had to write it here, write it here, write it here. That could be stressful. So instead of writing it multiple places, we just put it in a method and we'll call that method everywhere we want to use it. And get, so public static. So we want to do the same thing for this first line. Where is it? For this first line, this loan payment multiplied by yearly increase, the yearly increase ratio is for our years. We want to do it separately. So public static, let's say void for now, we don't know yet. we call delete loan cost no payment. So we can say get loan cost no payment, right? Then we'll put the formula, which is this. Control C. You can just return it directly, actually return that. Then we'll say this should be double, because we know the, so we need loan amounts, we need yearly increase rate, and we need years. So we know that loan amount is double, so double loan amount. We also need yearly increase ratio, that's also a double yearly increase ratio. We also need years, so years is an integer, so we can say years, right? So that fixes that. So instead of writing this whole thing here, we can just say get loan amount and supply the value, or we can just even do this double loan cost amount, right? Loan cost amount equals get loan cost. No, get loan. Oh, loan cost no payment. Don't mind me. Loan cost no payment equals get loan cost no payment. Then we supply loan amount, we supply yearly increase ratio, and we supply years. So all we need to do here is to just say loan cost, loan cost no payment, as it. So all we just did was bring out them, every group. This is a group, right? This is another group. Maybe they will talk about it later, but let's say you are working on yourself, and this could actually help you once things get complicated like this. Just break it down. Do this one separately, do the first line separately, do this line separately, do this line separately. It's easy for you to say method 1 over method 2 that is in the bracket over, instead of doing all this power, all this blah blah blah. You could just, everything will just be method 1 over the bracket of method 2 over method 3. Then you are done. Just 1, 2, 3, 4 forwards. You are done with this whole thing. But you would have done method 1 separately. You would have put this whole thing inside method 1, put this whole thing inside method 2, put this whole one inside method 3. So all you need to do is yearly payments amount equals method 1 over method 2. Sorry, over the bracket of method 2 and method 1. One other thing you can do, you can also have method 4. Method 4 equals method 2 over method 3. So all you will have here is method 1 over method 4. Bam, you are done. Just doesn't have to be this complicated. You can easily break them down. Imagine if we also brought this one plus this one over this one. If we had to bring it here, bring it here, bring it here, then this will be about 7-8 lines of code. But they broke it down. They did this separately. Then you can also do this whole thing, like this whole line separately, then do each of the lines separately. That's what they are doing. So all they did was take this one and do it separately. So instead of having this here, the only thing they need to do is loan cost amount over all this, which you can see here, loan cost amount over this instead of the formula itself. So if you want to get the monthly, to compute the monthly payment, you need to divide the yearly payment by amount by 12. So we know we have the yearly payment. So to get the monthly payment, we can just take out the S out. Double monthly, it's called monthly payment. Monthly payment equals yearly payment. We already have yearly payment amount. Yearly payment amount over 12. Wow. Right, that should give us the yearly payment. Now this thing that is just 3 lines here, this could have been it. It could have even been bigger than this, because loan cost amount, don't forget, loan cost no payment is this long one again. Now don't forget that this yearly increase ratio is this mighty one again. So imagine if we slot this year, and somewhere here, this could have been like 10 lines. But because we've broken them down into several pieces, then we could just get our monthly payment easily. So this whole thing that they have written here is what I've done with just one line of code here, because I've broken this yearly payment amount down before. Those are the uses of methods. Okay, so that should give us, did they give an example? Yeah, that should, let's see what we'll get. Just a minute. That's out. Monthly payment 780. Is it 780? Yeah, 780.66. You can see. So it's the same thing. So we can also, so our yearly increase, let's also bring in yearly increase, so we know we are done with everything there. So yearly increase ratio. So 1.08, monthly payment 780.65, 780.65. If you want to format it, you can easily do that. F, comma, no, it has to be %.2f, then comma, yearly monthly payments. So that you see that. Okay, so we're done with that part. So part 2, which is I don't know. Okay, I think they want to calculate amount owed in years. So let's okay, the tax is actually, yeah, that's fine. Okay, so now that we have the yearly increase ratio and the monthly payment, we can list interesting aspect of the loan over the years. We need to perform some calculations first. The entire formula to calculate the amount the borrower owes at a specific year is this. So we want to calculate amount owed, right? So now we can take out these ones for now. So double, well, we can actually just put it in a, okay, let's just double amount owed equals loan amounts, yearly increase ratio, blah, blah, blah. Let's just go with the spirit of methods, right? Let's create a method for it. Say public static, we know we are getting double, but let's leave it as this for now. Then let's call it get amount owed equals that, right? Then we're expecting loan amounts, we're expecting yearly increase ratio, we're expecting year, we're expecting monthly payment, and I think that's all. We already have yearly increase ratio. So let's take it one by one. So double loan amount, then double yearly increase ratio, double yearly increase ratio, then we need year, that's int year, right? And also monthly payment, right? Yeah, monthly payment, that will also be double monthly payment, right? So we can now write the formula, which is double amount owed equals loan amount multiplied by the power of yearly increase ratio by year. So max dot power, that will be yearly increase ratio by year. One thing, what comes up when I type is just a suggestion by the system. If it's not what you want, take it off like you've been seeing me doing. Don't just think that is how it is. you can notice that when I typed math.power, it wrote some things there in the bracket automatically. It's just his own suggestions. These things are thinking themselves now with the help of AI and stuff. But sometimes even humans get it wrong. The same way we sometimes get it wrong. So you can always change the values to what you want. Exactly. Okay, so minus a big bracket, then a small bracket that does this complex calculation here. That's 12 times month, 12 times monthly payment times another bracket, maths, yeah, math.power. That's yearly increase ratio by what? By years minus 1. Yep, I think we're right on track. Yeah. Okay. So to now get where we want to put the next bracket, now you just need to check out, okay, the brackets before 12. The brackets before 12. What's the brackets before 12? This is yellow brackets, right? So where does it end here? Then after it, you put here. And I have a new bracket, yearly increase ratio. Don't mind this one. Yearly increase ratio minus 1. Sorry, minus 1. Terminate it and save it. Yeah, that's it. Something is wrong. Something is wrong. What is wrong? Oh, interesting. Where are all these ones? I might have to do this again. So this one ends here, this one ends here, this yellow one is this one. Yeah, I definitely have to do it again. Yeah, that's one thing with this thing. I think I lost track of something at some point. Okay, I don't actually. Yeah. So basically, this one, this one is different. So the first bracket, the big bracket, which carries the whole thing, that's it. Then the brackets before 12, which is this, that ends here. No, missed something. Where's the divide by? Fascinating stuff. I just have to start it again. Don't worry, that's fine. So we are at loan amount multiplied by math.power of that minus this bracket, right? Then a smaller bracket that's 12 times. What is monthly payment? Monthly payment times yearly, that will be times a bracket of math.power that will be yearly increase ratio by years. Then right after it we have minus 1. So you can see that this bracket encompasses the power and the minus 1. So that means it's in one thing. Then that whole thing is closed. Then we need this one under. So that will be the bracket before 12. So the bracket before 12, which is this, that will be divided by yearly increase ratio minus 1. That started, yeah. So that's it. So this was the divider I was looking for before. I don't know why I skipped that. So this is it. So the first part, you will split this down in a minute. You will see that instead of the me racking my brain to figure out where the bracket goes. Had it been we've done things as we've done here, it would have been a bit easier, but we'll come back to that in a minute. I think I just left this there to show how complex this thing can be and how things can be complex. So basically, you can just return amount owed, then we can call this double because amount owed is a double. Then, however, it is often easier to split complex formula into smaller ones, as this renders the program a lot easier and will allow you to create a series of methods to perform this calculation. You can remember we did this loan cost no payment earlier. You can see that it's almost the same thing as one of these things. Yeah, let's see. Yeah, it's the same thing as this. Right? So instead of writing all these things again, we could just say, okay, we actually have it here. So instead of doing this whole blah blah here, I could just say get loan cost no payment, then supply loan amount, supply yearly increase ratio, and supply GS. Although it could still be longer, but at least you know what you are doing with that point, and it's just one sentence. The only thing you are typing is just get loan cost no payment. The rest are just parameters, so you know what you're doing, right? And deduction ratio, yeah, saying we could also do. I think they are using deduction ratio. Now, rules for methods are just like one of the points where you discover you have to start creating method is when you discover you are writing things multiple times, right? Like this yearly increase ratio we've done, since you can see how many places we've used yearly increase ratio. That was why we made it a method. So we could just call that yearly increase ratio anytime we want to use it, right? Same thing goes for this get loan payment. You can see that we've actually been using it multiple places now. That was why we made it a method. So when you start discovering you are using some things in multiple places, just take it out as a method. So I think at some point too, they want to use this deduction rate. So they're taking it out. So we can just say, create another method for deduction rate. Public static void get deduction ratio, get deductions ratio equals is looking for just yearly increase ratio and year. So there is no equals plus. So we say double yearly increase ratio, and we say our year is always an integer, int year, right? Then let's put the formula. That's 12 times and just a return, actually return 12 times our big brackets, our small brackets, yearly increase ratio by year. That's math.power yearly increase ratio by year. That's fine. That's what we actually want. -1. Then before this whole thing started, which is the yellow bracket, we want divide by, then another bracket, then yearly increase ratio -1, and that should be it. And we can change this to double. Now, if you look at this formula here, this 12 times this, you would say that it would looks like 12, 12 times this thing, like this is the same thing as monthly payment times 12 times this. This is the same thing as this. Now, this mathematics, I don't know how to start explaining this actually. This over this is the same thing as saying 12 times monthly payment times this value over this value. I don't know if this is making sense. 12 times monthly payment times this small bracket over this small bracket is the same thing. Is it the same thing or not? Do we get that analysis? Hello?
Yes, you are flowing. It's the same thing.
Okay, so this like this multiplied by this over this separately is the same thing as this thing they've written. So we can also say monthly payment times 12 times this over this is also the same thing. So that's the same thing as 12 times monthly payment by year minus 1 over yearly increase ratio minus 1. So if we want to bring in this one now, we could just say times monthly payments, but we'll come to that in a bit. But what they are saying is, I think they are using this deduction rate somewhere else down the line. Let me see if I can find it. Yeah, I don't know, but they just made it. I think it's a formula on its own for something else. Deduction ratio, like what's the deduction ratio in the company for the loan? So where was I? Yeah, I was here. So this is the same thing. This like this is the same thing as this minus just this one, which we could easily say multiply by monthly payment here. So we've written, I think we've done deduction ratio. So we could just say, because we've already taken care of 12, we've taken care of year minus 1, we've taken care of this one. So we can say deduction rate multiplied by monthly amount. So everything here goes to everything we are still working on this amount old. We can see that it gave us some headache while we were building it. So we are trying to reduce what we actually typed. So this has been taken care of. This like this has been taken care of. It's the same thing. Max.power yearly increase GS minus 1 divided by yearly increase ratio minus 1, which means we can say something like this: monthly payment multiplied by 12, same thing, right? I just interchange them. Then I can say everything like this, because we already have it. Everything like that is just get deduction ratio, and we'll supply it with the yearly increase ratio and also the GS. And I think one bracket is missing. Introduce it, and you can see it's getting smaller. All we needed to put here was, let's actually make it interesting. Double loan payment no cost equals get loan payment no cost supply loan amount supply yearly increase ratio supply year. So everything here is just loan payment no cost, right? Then get to deduct, we can also say double deduction ratios equals get deduction ratio supply yearly increase rate supply years. Then let's take it off. Deduction ratios. Now everything we were writing that time that was giving us headache, you can see how we've taken it down to something simpler by just decoupling stuffs and doing them inside different. As long as you can group those things and you'll be using it someplace else. The same way we've been using this get interest ratio almost everywhere. You can see it is everywhere. This get loan payment, you can see it multiple places also. Then you group them together and it makes your giant calculation just 3. 1, 2, 3. And we can even take this off. We don't need this many brackets again. And you still get the same answers. So that's the reasons for method. So all you are left with is loan cost no payment minus deduction ratio minus payment amount, which is the same thing as this thing here. But we've broken all of them down into we've categorized some encapsulation into different methods to now make it simpler. Okay, so I think this is just notes. In part 1, you should code the formula in the main method first, although that was not what we did. That wasn't what we did well. Actually, that was what we did because we've done these are monthly payment method before. It's just saying everything we've split up off like this, we should have done it inside the main first. Then once we do it inside the main method, then we can start. Okay, this one looks okay, just the same thing we did here before. We did everything inside just one big dial. I had to do it 2 times because it got lost at some point. Then we started breaking it down until we had something simpler. So you do it once first, then you start breaking things down. So you must declare the necessary variables to the value as an int. Suggestion of variable names have been used in the formula, and the test value table will display the wanted values in the console. So this is the wanted value. Ratio 1.08, monthly payment 78.66. So we can come back and say S out by 1f ratio is percent 2f, and monthly payment percent dot 2f, and that will be the first 2f is the yearly increase ratio, and the second one is the monthly payment. And that gives us ratio is this, monthly payment is that. In part 2, you are going to use the method above to continue coding the solution. The goal is to create some code to compute the payment made and the amount owed at a specific year. Then you can port the code into your own method and use them to display the borrowing details using printf method. So the get loan method is using and so is the yearly increase ratio. So what we want to do is once this now we have year, we have ratio, we have monthly payment, then we need amount owed at each year for 25 years. Like you borrowed you borrowed 100,000 pounds, you paid this particular amount, then this is the amount owed after 1 year. This is the amount owed after 2 years. This is the amount that has been paid after 2 years. Like that until the last bit where you've paid 234,000 for a loan of interest rate now, for a loan of 100k, and you are done, you are not owing anything again. So let's see if we could bring that up. I think that is this amount owed. So this years is actually going to be year, not years, because we want it by year. So just naming convention doesn't affect anything right now, but I just want the naming convention to be fine. It will be per year because we are calculating for each year, not the whole 25 years. So it will be per year. So let's try and S out that and see what we can come up with. S out. I'll use F, right? Then I need year. That will be okay because it's going to be a loop. I need a loop first. So for integer I equals 1. Remember our loop. I less than or equals to yes, which is 25, yes. I plus plus. Then we'll bring our S out inside. So we want to S out 25 times. S out, yeah, that will be I, right? So %d. We'll come back to that in it. Oh, no, let's come back to that. Yeah. Then we have ratio, which is our yearly increase ratio. Yearly, which is %2f. Then we have monthly payment, which is %2f. Yeah, that's fine. .2f. And we have amount owed, which will also be %2f. We have payment cumulation, which is also %2f. Then let's start soliciting year. That will be each of the years. So if I put years here, what I will get is year 25, year 25, year. That's not what I want. I want each of this year, which is starting from 1. So what I want here is I. Then the ratio, that's the yearly increase ratio. So yearly increase ratio. Then monthly payment, we've gotten that from here, monthly payment. So monthly payment. Then amount owed. So this is where we calculate amount owed. So we'll say double. Double amount owed equals, we want to get, because we don't need to write it again, we've already done this, so we just do get amount owed. Now we'll supply what is the loan amount. The loan amount is loan amount. Yeah, the yearly increase ratio is the yearly increase ratio. The years will now be I, not years. Then the loan amount, monthly amount is monthly amount. So let's see if that makes sense. So monthly payment. Then we need accumulation. So everything that has been paid. How do we know what they have paid? How do we know what they have paid? Accumulation. I'm coming. Oh, okay. No. Just a minute. Let's take it one bit at a time. I'll take this off for now. This is the only thing we don't know yet. No, there should be amount owed. No, that's ugly. Okay, let's see. What do we have? Does it make sense? Yeah, I think it makes sense. So this is not really, doesn't make much sense. 98,632. No. Why is that? 673.96. Oh yeah, this is it. Actually started fine. I think. Oh, this is it at the top here. Don't mind me. Take this off. I can take it off. I could just use printing line. So yeah, it started fine. 98,632.12. 98,632.12. So we need to figure out what this is. So what is this? This is the amount, the accumulation of the amount that has been paid by the year. Oh yeah. That's get Yeah, that will be this. That will be this, but this is loan. Yeah, this should be 780 times 12. Let me see. 780 times 166 times 12. Yep, that's it. We need to figure out. Yeah, basically what this is this is payment amount, monthly payment amount, but we are calculating by year, which means what we are doing here is for every month, like for every year like this, we are multiplying this. We are doing this. That means they've paid 12 times. That is what we are doing here. On this one, they've paid 24 times. On this one, they've paid 36 times up until 25 years. There are 12 months in a year. So that's where they're getting this payment accumulation. So one thing, just figuring out how best to get that. Double amount paid. Okay, we can actually do that outside. Oh, yeah, we already have yearly payment amount actually. Yearly payment amount. Yeah, one thing we can do is get what yearly payment amount is for each of the year coming. I just want to. Sometimes this thing takes going back and forth to figure out what the value is. So I need yearly payment amount. Yearly payment amount. Let me see what that is. Yep. No, it's just one. So one thing I can do is instead of doing this yearly payment amount here, I can do for each year separately. I collect years. I'm coming. So it collects. Oh, there are a lot of things this actually collects. Thinking of the easiest. I'm just thinking of the easiest way to do it, but I think the easiest way to do this is to just say double. That will be. We just say double accumulation. Now I'll have to show you something here. Equals 0. I don't know yet. Now, the reason why I had to put this accumulation outside of my for loop is because I want it to be accumulating for each year. So for the first year, to come out of the loop and say, okay, the first year they paid £9. The second year it will increase this one. But if I had put it inside the loop, if I had put it here, for instance, double cum, because it won't do that. It will just come and say, okay, the first year they paid 8. Once you start the loop again, double, like this cum changes back to 0. Now that's one common mistake with loops. You want to be accumulating something. You want to, like what we did yesterday with the dice, you want to be accumulating one particular overall time they played, right? So it has to be outside the loop, so you don't keep, because one thing that if you put anything inside this loop, every time the loop start again, it changes the cum to 0. So if you say on the first thing you change this to 9, on the second thing this thing has changed back to 0, it's no more 9. On the third, it's still back to 0. On the fourth, it's back to 0. So that was why I needed to put it outside of the bracket so I can maintain current value. So if I say 0 here, then I can come and say, okay, cum, right, plus equals to 12 times monthly payment, right? 12 times monthly payment. That should give me cum. I will still show you one other way to do that, but that's just the easiest. And cum That just that's very wrong. That's very wrong. Very. Oh, that's not what I want to do. Let's do that again. Yeah, that is what I want to do. So all I did here was say cum plus or equals. Plus or equals means cum equals cum plus everything here. So plus or equals just makes me not write cum 2 times. So cum plus or equals, then I want to say this is monthly payment, right? But we are calculating by the year. So just multiply it by 12, which means at the end of the year, the person has paid 7,866 12 times. That gives us this. At the end of year 2, they've also paid 7,686. So we add the current one with the previous one, giving us this up onto the last payment. I don't know if this makes sense. Another way you could do it is find a way around this yearly payment amount. I think this should be the same thing as this first year. So you can just do times 2 times 3. So let me see. Double cum 2 equals cum 2 equals yearly payment amount times, I'll just do times I. So for each year times I. Then let's see, cum 2. Yeah, it's still the same thing. So I guess this is actually, the second one is actually more easier than the first one. So all I did was, I know I've been calculating yearly payments before. It was one of the methods I've written earlier. I could have put this inside the method too and be calling it. So I know I've written yearly payment before. So all I need to do was every year, I will just be multiplying that yearly payment by the current year. So on year 5, that will be, they've paid yearly payments 5 times. So yearly payments times 5 gives us the whole amount that was paid as at year 5. Does this make sense to everybody? Hello?
Yes.
Okay. I think that is it. You can follow this code. It might be a bit different from mine, but should still be good. Yeah, and I think that's it. Do we have any question? Do you have any question? Okay, if we don't, we're good. Evening, everybody. Take care of yourselves. We'll see class tomorrow, I think. Yeah, bye, everyone.
Thank
Okay,
you
Anthony.
so much.
Okay, just a quick one before you go. I noticed that you did something when you were trying to call one of the methods. When you call it in the parameters, I think instead of returning principal, wanted principal, and one other thing, the system actually returned principal and principal again. So I saw you corrected it yourself.
Yeah,
to
that
change it
was
to wanted
what
principal.
saying.
What happened there?
Most of the current what's it called? The current VS Code, they are using a bit of AI these days. So what it's doing is that once I type a method, it will just use the method name and try and figure out what's the closest. So if I type, let me say I type get months now, it will just check, okay, what are the closest thing to the method definition? Look at the method definition. The method definition says I want principal, I want wanted principal, I want rate increase ratio. So you just look at that name and look at the variables I have in my system and just slot them in. But if I don't, let's say this rate increase ratio is actually not what I want to put, I can easily change it to rate. They are just suggestions. You don't have to go with them.
Yeah, I had that experience. So I was thinking that my system was misbehaving. So I got it now.
Your system was not misbehaving. Let's do that again. So get month. You can see I don't have the wanted principal. So you just figured, okay.
Exactly.
This principal actually looks like wanted principal. So let's just use it. It's just a bit of AI. Don't mind them. Sometimes it's not sometimes AIs are dumb. They just figure, okay, let's do this. But it is you that notice, I don't want two principals. I want another kind of principal. Then you can change it to any principal you now want, depending on what you want. So let me just go back to the wanted principal. So this was what happened the other time. I didn't have wanted principal before. So when I typed the method, it was looking for wanted principal. I couldn't see. So it replaced wanted principal with principal twice. You get the gist, Val?
Yeah, absolutely.
Yeah. So any other question? Okay, all right. Have a good evening, everybody.